So we're going to finish up what we were talking about yesterday. So yesterday we started with our partial fractions, which was a way to take a rational function and split it into two pieces so that we could actually integrate it. This one, if we try to do partial fractions, poses a problem because the numerator is to the fourth. For the most part, partial fractions is only useful if the numerator is to the first or just a constant. If it's any bigger than that, then usually it either won't work or there's a much more complicated process to get it to work. So we have to do something else first to simplify this before we can actually then do partial fractions. You know, that seems crazy because partial fractions took a lot of space and time all by itself. But we're going to do two things. And I know it's your favorite thing from pre-calculus. Your favorite thing ever. We are going to divide polynomials.
Oh, crap.
So we're going to actually take the denominator and divide it using long division into the numerator.
Oh, yeah, I was right. I do hate this.
Oh my gosh.
I wasn't lying. It's usually...
I was just saying it because, you know, you said we love it, and I agree with myself.
So one thing we had to remember when we were dividing polynomials is we needed placeholders for everything. We need a 0x cubed, a 0x squared, 0x, and then plus 1. And some may or may not be needed, but you have to put them there so that if they are needed, you can use them.
And what are all the zeros from?
We're just doing placeholders. We have to have every exponent involved, 4, 3, 2, 1, 0,
Okay.
in order to do this. Just like if you had 1003, you couldn't just divide into 13. You need those zeros as placeholders because it's the 10 spot and the 100 spot. Well, this is the cubed spot and the squared spot and the linear spot, so they all need to be there. So when we did long division with polynomials, we took our highest degree outside, so x squared, and we asked ourselves the question, what would I have to multiply by x squared to make the first thing inside of the, I think it's divisor, dividend, whatever, the divide sign. So what would we have to multiply x squared by to make 3x to the fourth?
3x squared.
3x squared, so we line it up with our x squared columns. 3x squared. And then we had to multiply that 3x squared by everything in front and put it underneath. So we had to do 3x squared times x squared, which gives us 3x to the fourth. 3x squared times negative 1, which gives us negative 3x squared. And then in old school division, after we did that multiply step, what do we do next? Subtraction. So we're going to subtract this entire thing, which will change the sign of everything. So the 3x to the fourth would become minus, but the 3x squared would become plus. So 3x to the fourth minus 3x to the fourth cancels. 0 minus negative 3x squared becomes positive 3x squared. And then we bring everything else down. And we do it again. So, again, we ask ourselves the question, what would I have to multiply x squared by to now get the first thing of our new polynomial? 3. X squared. Yep. So we have plus 3. Again, I'm going to line it up with its like term. So now we know we're almost done with our division. Once we get this last term, we know we're almost done. We multiply again. So we get 3 times x squared is 3x squared. 3 times -1 is -3. And again, we subtract. So you could either put parentheses and the subtract sign out front, or I usually just like to change the signs. I usually just go negative, positive, just change the signs of everything. You just have to remember if you've changed the signs or not, if you ever lose your place in the process. So those cancel, we get 4. So this is what we get our answer as, with a remainder of 4. We're going to have to use the remainder in this case. So that means our original polynomial, 3x to the 4th plus 1 over x squared minus 1. I'm not even going to write the integral sign right now because we're not even to that point yet. Really is what we got for our answer, 3x squared plus 3. Yeah, plus 3. And then since we have a remainder, it's plus the remainder over the original divisor. Make sure that's the correct math term. So now I do have some things I could integrate. What could I integrate on that right side so far? 3x squared, pretty easy. What about 3? Pretty easy. Then this last piece is one of the reasons we learned partial fractions. Now I have to go through and do the partial fraction process to split this up enough. Yeah, that's why we're only doing like 2 or 3 problems on the homework. We have to split this last piece up enough to integrate it. So looking at just the
Difference of 2 squares.
yes, and Emma recognized the factoring. X squared minus 1 is a difference of 2 squares. So we know we have some constant that we have not found yet over x plus 1 plus some constant over x minus 1. We're trying to take our original fraction and to split it into the fractions that would have been used to add together to make the 4 over x squared minus 1. So we showed last time we actually had to multiply everything by x minus 1, multiply everything by x plus 1. But you can kind of come up with a shortcut. We know the denominator here will disappear, and this one will go up by the a, the x plus 1 will go up by the b. Makes it so we don't have to write out all the multiplication that we're doing. So we get 4 equals a times x minus 1 plus b times x plus 1. So we know this equation is true no matter what x we pick, but we try to pick our x specifically to get rid of our a and our b. So what do I pick x to be first to get rid of a? 1. So that means we get 4 equals a times 0, so it disappears, b times 2, I should have written the 2 in front, but I already started writing b, so I don't want to erase it. So that means we know b is next we plug in -1 to get rid of b. If I substitute -1 everywhere I see x, I would get 4 equals -2 times a. The b disappears because we multiplied by 0, so a is -2. So finally now we have this split up enough that we can integrate. So we have, in total, using both our long division and our partial fractions, we are now taking the integral of 3x squared plus 3 plus, the first one was a, we said a was -2, so -2 over x plus 1. It's very important you put the a and the b in the correct spot because they go with their associated denominator. So I did have to put -2 first, plus b, which is +2, So we did all that so we can integrate, and now we still have to integrate.
You're making me so happy.
So lucky to be able to integrate this.
Yes. We are going to do a try problem as well, but
Oh.
we're running out of room, so have to move stuff down. Okay, so the first two pieces pretty easy. 3x squared is going to be
X cubed
x cubed
plus 3x
plus 3x. Thank you, Ben.
plus...
So then,
I'll see that one.
these ones we do have to use sub. Now the top number is just a coefficient that goes out front, so the top number just really goes out front. But it might be affected by what happens when we use sub. In this case it won't. But we have to take the denominator and find what dx would equal. Dx is du over 1. So we really have the integral of 1 over u du. And what do we know the integral of 1 over u is? Ln absolute value, and then we just plug x back in. So like I said, there kind of is a shortcut on these. As long as it's just a first degree polynomial in the denominator, I really can just use the coefficients. It's -2 over the coefficient in front of x1, or 2 over the coefficient in front of x1. If it was 3, it'd be 2/3 that we put up front. Or you can just do u sub every time if you don't want to try and remember a shortcut, because it only works in specific situations. So the next one we'd do the same thing. This time use x minus 1. Dx would be du over 1. So again, we'd get the integral of 1 over u, but this time we'd have a positive 2 out front, so we get plus 2 ln of x minus 1. And what should my last thing be? Plus c. I almost put dx again, so I had to pause for a second. But I know there needs to be something there. And now they probably would combine your logarithms. When we have logarithms, if there's a negative, that means that will be the bottom part. So we don't have to like rearrange everything in order before we apply the rules of logarithms. All they would do is 3x plus, they'd factor out the 2, which would be a squared on the inside. They'd say 2 ln, and then they'd put the positive one on top, the negative one on bottom, because negative meant divide. Or if they were both positive, we'd be multiplying instead. And then we can also, since there's a 2 out front, square the entire thing. Which means since the entire thing is squared, I could drop the absolute value bars at this point. Because if I square a number, no matter what's inside here, it's going to come out positive. So sometimes they will also drop the absolute value bars. So do you want to do a try problem together as a class, or do you just want to get started on the homework? Does that sound okay to everyone? Okay. I'll come around and help you individually since we're going to have, I swear,